Two pulleys have a radii of 15 and 8. The larger pulley rotates at 30 times in 46 seconds. Find the angular velocity of each. Well, let's work with our larger. Our angular velocity is a change of the angle over time. If we want to find our angle, I should write this as our larger one. Our angle is going to be 30 rotations in 46 seconds. So 30 times our 2 pi will give us our angle. So we'll have 60 pi radians over our 46 seconds. So our angle will reduce to 30 pi over 23 radians per second. That is our angular velocity of the larger. Well, to work with our smaller, we need to find our linear velocity of the larger, so still working with our larger. The linear velocity is our distance over time, but we're going to change that distance, the arc length, to r times theta. So looking at our larger, we will have our radius of the larger is 15, and that's going to be using our angular velocity that we already found. Do you see that? That theta over t is our angular velocity. So theta over t will be our 30 pi over 23. So our linear velocity would be 450 pi over 23, and that would be centimeters per second. And that is for our larger. We had to find that because our linear velocity will pull, and that length will rotate and impact the smaller. So now let's work with our smaller. If we want to find our angular velocity, our angular velocity is our angle over time. What we probably need to start with, though, is our formula. That's our end game. Is our formula of linear velocity is r over theta times t. Very similar to what we did above, but now we have our angular velocity we're going to be finding. That's angular velocity of the smaller. And what we use is the linear velocity of our larger one derives that smaller one. So we're going to plug in our 450 pi over 23 in for our v, our linear velocity. Then our r for the smaller one is 8. And we're looking for our theta over time, which really is our angular velocity. To finish getting our angular velocity by itself, you can multiply by 1/8. And our angular velocity, that will simplify to 225 pi over 92. And that would be radians per second, and that would be the angular velocity of the smaller.